Alright, so we've talked about the different specializations inside of mechanical engineering. Okay, it's time to be quiet or leave. Your choice. Choose whichever you like. Doesn't matter to me, but don't say talk. Okay. We started talking about specializations within mechanical engineering, and I asked you to think about which of the 4 main specializations you would like to be part of. So we're organizing the class now where people are sitting according to the specialization. So, if you think you're most interested in solids and structures, those kinds of topics, you should sit in the first 3 rows up here. If you're most interested in fluids or thermal, sit in the back 3 rows back there. If you're most interested in dynamics and control, sit in the first 3 rows up here. If you're most interested in mathematics or computer science, computer topics, sit in the back 4 pick a specialty journal that's in your field and review two papers. And be quiet. Alright? There's a very simple rule. Either listen to me or leave. And I don't really care either way, so I'm not insulted. If you don't want to listen to me, it's okay with me. But don't stay here and talk. If you're going to stay here, you have to stop talking. Does everybody understand that? Okay. Thank you. Now, the assignment is to look at the ASME website, find a journal that's related to these specializations, and you have to look at two papers, two recent papers. Everybody does a different one within the group, so you have to talk to each other. And you figure out what is the paper about, the basic topic, and where do the authors come from. Okay? Where do the authors come from? So that's that first assignment. That's from yesterday. So today I'm going to add a little bit. Within your group, let's divide into, what's a good number of pieces? Let's say 3, 20, 15. Yeah, we'll make 3 groups inside of each specialty. Okay, so, and 4 back here. So 4 groups. So 5, 6, and 6. And for this one, we'll make 3 groups, 5, 5, and 4. For this one, 3 groups, 5, 5, and 4. And for this one, 5, 5, and 6. Okay? That's the number of people in each group. Alright, so we'll start, we'll do it, yeah, we'll do it in just a minute. Then within each group, I want you to do 2 things. Compare the courses in UP and the ME at NUT. In other words, this is not the advanced program, right? The regular mechanical engineering program here. In your field. Who has a question about what that means? So for instance, if you're in dynamics, you already have an assignment where you looked at the curriculum at UB to figure out what the different courses are. So now look at all of the dynamics classes at UB and look at all the dynamics classes that are required in the regular ME program, not the AP program, at TNUT, and compare them and see how close they are. Okay, see what the difference is. Same thing in the math, computer science, same, yes? Yeah, if you don't, the question is, what do you do if you don't find anything that's approximately in your field? Okay, well, I can tell you that at UB there's some things in every field. So it will be interesting, I made it for you, to see what the idea of the TNUT is about ME. Because like I said, the curriculum is normally fixed by the faculty. So maybe the faculty here has a different idea of what's the most important thing. What are the most important things? I believe, but I'm not sure, that I'll put this out as one idea, something to look for. I believe that at TNUT, there are more courses that would fit into this category than there are at UB, and maybe less courses in these other ones. I think the ME program at TNUT is geared towards, a little bit, towards materials, machining, a lot of solids. So maybe these two have a lot and these two don't have so much. But that's up for you to figure out. Okay? Any questions about that? Yes? Yeah, so compare the number of courses. Let's say the percentage of the program. Because number of courses isn't always a good measure, right? Now, I said the currency of a U.S. degree program is credit hours. So at UB, for a bachelor's degree in mechanical engineering, you need a certain number of credit hours. Right? Something you were supposed to figure out. But the number is about 130. So let's say that you discover that there are 5 courses, and they add up to 20 credit hours in solids. Then the percentage would be 20 under 30. Okay. Okay. Let's do, under the number of courses, might as well do the names too. And maybe a 1-sentence summary. So the first course in dynamics at UB, some of you just finished, EAS 208. Write the name of the course and just a brief summary, one sentence or so, what it's about. And then C is the same course, something like that, in the regular ME program at TNUT. Okay. And right now, some of you are beginning the first course. It's not really the first course in math, but it is the first ME course, the first engineering course in math and computer science. So compare the ME programs in this category. All right. So for instance, at Buffalo, and I'm sure also here at TNUT, there are courses that are just pure math, like maybe you take calculus or something like that. Don't count that. All right, that's part of the background. But a course like higher level language, that's specific for engineering, so you count that one. Okay, any questions about that one? That's the first part. All right, the second part maybe is more fun. So you did a project already, or homework already, where you wrote down 10 inventions that are based on nature, 10 that aren't based on nature. We talked about the whole point of engineering is to create the world that has not been. Okay, so now we're going to create the world that has not been. So in your group, propose 2, I'm not sure what I'm going to call them. Let's say new things from your field. So now you're the inventor. You don't have to know how to make it work just yet. But let's say that you're in the fluid thermal. Okay, so maybe one new thing. If I say it, you can't use it. Okay, so I'm going to say this one. It's going to take it off. But maybe one new thing would be air-conditioned clothing. Right? So instead of having that air conditioner, we all just wear clothes that are air-conditioned. And then we're cool inside, outside, doesn't matter. That would be pretty slick, I think. Air-conditioned clothing, I like that. But now you can't use it. You have to come up with your own. So 2 new things that fit into whatever your specialty field is. And they can be, an actual object, or, like we talked about, it could just be a new procedure or process. All right, so what's an example of a procedure or a process? Maybe I'll put this one back for the computer people. Right, so maybe you propose that there's a new procedure for dialing telephone numbers that's easier than the current one. Something like that. You're not going to invent a new telephone. You're going to invent a new procedure that makes the telephone easier to use. But you need to say what it is. So I wasn't very specific. You would need to be more specific. I'm going to make a telephone easier because I'm going to implant a chip in somebody's brain. And all I have to do is think of that person, and it automatically dials the number and calls them. Okay? So there, that's the new invention.
In that assignment, we just propose an idea, not.
Yeah, you don't have to solve it yet. Okay? So two ideas from each group, and we're going to have 4 + 3 + 3 + 3, so a total of 13 groups. So we're going to get 26 new ideas out of this group, out of this class. 26 new ideas to make the world even better than it already is. Okay? And then what we're going to do is of those 26 ideas, we're going to make the number smaller, maybe something like 6 or 7. We'll decide. We'll have a meeting. We'll discuss. And decide on the best 6 ideas, or 7 or 8. And then we're going to try to do it. Okay. But we won't, in most cases, it will be impossible to finish them. It will require more resources than we have available. But we can at least do a design and make a list of what we need, right? And how long and so on. We'll get to that part. So this exercise is going to generate 26 project ideas. And we're going to pick the best, let's say 6. We'll pick the best 6 ideas. Okay? Maybe we should have a prize. The groups that come up with the best 6 ideas get some kind of a prize. I'll think about it. Okay, any questions about this? Yeah, there are 2 groups that only have 4, so they'll have to be very smart people. Yeah, so the question is about these, I think has to do with the projects, right? So there are going to be 3 groups in solids. Each of those groups are going to propose 2 different projects. So in the total, we'll have 6 different solid projects proposed. We'll have 6 different fluid thermal projects. We'll have 6 different dynamic projects. And we'll have 8 math and computer projects. Okay? Now, it's okay. It won't be easy to come up with a project that only covers one field for all 26. Some of you might have a project that you think of as it's bigger. A lot of projects will have at least a little bit of computing in them. That's okay, but the primary piece of it, the biggest part of it, should be from the specialty. Yes? For this part? The original summary of 12 people for each group? Yes, the papers, yeah. You keep working on the papers too. That's still separate. No, two per person. Two per person. So the solids group needs to review 28 papers. Fluids needs to review 32 papers. Total. Two per person. Each person does 2. Yeah. Yeah, maybe that's an unnecessary restriction. So let's not say the last 2. Let's say any 2 in the last 5 years. Okay.
If we want to like prove the numbers,
Yeah.
Otherwise, we just can see the abstract.
That's right. Yeah. So the abstract gives you some idea what the paper is about, and that's all that I need to hear from you. It's just an idea what the paper is about. But not a copy of the abstract. In your words, 1 sentence or so. This paper is about using a laser to measure the displacement of a building, for instance. Okay?
Speak to new articles and draw and write the open papers.
If you could write the whole paper, that would be awesome. I think that's a couple of years later. Is the internet working back in the dorms? It's working again? Okay, because it's not working in my apartment. So I was going to go online and maybe do some of just go through and show you what I have in mind for one paper. If this is online, I can do it now. Can you tell if that's online? Is the internet working? Okay, there's no internet working, so I can't do it. But when you look at the titles of the papers in these journals, some of them will have words in them that even though it's in your specialty area, you probably won't understand. right? That's not unusual. So, some professors believe that the most important thing and the most pivotal thing to become a practicing engineer in a certain field is to finally reach a point where you can read the paper and understand it. Because the language is so advanced, the topics are so specialized. For a normal person, they have no idea what it's about. And even sometimes for an expert in the field, like I consider myself a dynamics expert. So I can look at the dynamics journal and maybe there's 15 papers, and 10 or 12 of them I know exactly at least what it's about. I mean, I don't know the results. I have to read the paper to understand the new result. But just from looking at the title, I know what the topic is. But there might be 3 or 4 where I look at it and, gee, I don't really even know what the topic is. I'd have to read more just to understand what it is, even though I consider myself an expert in the field. So this is the result of the humans pushing the state of the art farther and farther out. But the farther it goes, the narrower it gets. And so every person has a very small specialty. So I know I've asked several of you about graduate school already. If you're interested in graduate school so far, I don't have a lot of enthusiasm. But I'll just mention something that is kind of interesting. When I started my PhD, I wondered, what does it mean to have a PhD? How do you know when you're finished? Because for a bachelor's degree, you have a certain number of courses. If you finish the courses, you're done. But for PhD, you have to write the thesis. And the thesis is like a book. And how do you know what to write about? How do you know when you're finished? And the answer is that when you first start, the professor is teaching you. But by the end, you're teaching the professor. So to get a PhD, you become such an expert in that field that you're even beyond where the professor was. And now you're the new expert. You pass him in that area. Okay, so that's interesting. That's the interesting part about going on for PhD. Okay, who has a question? Yes. You can choose. Yeah. Whatever you think is more interesting. Yeah. This is fun. Oh, it's a chance to look into something that you're already interested in, or you think maybe you will be interested in. So it's just a chance to read a little bit and learn a little bit. And the other part of this is it's practice and how you find new information. So in the future, if you come across a new topic that you're interested in, you know how to go and find it. You've already done this practice. Okay, that's the idea. I think it's really useful. I hope when you're done, you also agree. Okay. Again, I modified the journal assignment a little bit, so let me just say it again to be very clear. Each person has to do 2 papers, right, from one of the specialty journals in your field, but it doesn't have to be from the last issue. You can go back up to 5 years, I think is okay. But no 2 people should do the same article. Everybody should do 2 different. You write a 1 or 2 page, 1 or 2 sentence summary of what the main topic of the paper is, and then you also describe who the authors are, what nationality, where do they come from. Okay. And that part of it, why do I assign that part? Because I want to really drive home the point to you that the authors come from all over the world. You know, the leading experts are not all in the same place. They're scattered all around the world. Okay. Now, you've got a lot of work to do. So, I think that tomorrow we won't have a meeting. We'll meet on Thursday. Okay? But before you leave today, we need to divide into these groups. So, inside of each subgroup, okay, please listen, inside of each specialty right now, inside of solids, divide into 3 groups, 5 students, 5 students, 4 students. Write the list. Somebody be the secretary and write the list of who those 3 groups are, and then you can give it to them. In the fluids, 5 people, 5 people, 6 people, and so on. Okay?